And John is with Accenture, and we're going to chat a little bit about blockchain once again, hyper-reality, and use cases from the front line. Thanks.
Thank you.
Welcome.
Thank you. Hi, everyone. I have the enviable slot right after lunch on the last day of the conference, so hopefully keep this entertaining. The presentation I have today, I'm going to be talking about sort of use cases and things that we're actually implementing, projects that we're working on, and a variety of different things. So hopefully it's interesting for you as well. So first of all, before I get into any of the specific use cases, I want to just level set the audience about sort of what this technology is and what it isn't. A couple of things. First of all, when you take a look at sort of this technology, blockchain and distributed ledger technology, is very different than traditional IT systems. Traditional IT systems can be changed. You have basically databases, firewalls, networks, and so on, the thing that you see on the left-hand side. And on the right-hand side, you see sort of what the technology is capable of in terms of distributed ledger and blockchain. And it's consistent, it's durable. You share the same data store, you mutualize the information, it's encrypted by identity. And every single field and every transaction is protected by that level of identity that you have there as well. So very different in terms of the kind of technologies that you roll out, and it's important to explain that to people as well. I'm not sure how much that sort of comes out in many of the different presentations and stuff. First of all, I guess if we take a look at also the kind of types of technology, blockchain technologies, we've implemented a number of different use cases, and we can grossly categorize them into two major areas. The first one is really value transfer, tokens and messages going back and forth from the sender to the receiver. In that, you can basically send the message and send the tokens as well. So Bitcoin is a prime example of that. We've also decoupled the tokens from the messages and implemented a number of use cases where no tokens change hands, only messages. We don't have tokenized assets in some cases, and so you can actually do a lot of clever things with that. And in addition to it, you can also mutualize information. So you can use a data store or a ledger, basically, where a number of participants write to the ledger and read from the ledger, and everyone uses it for information exchange and using it as a golden source of truth. So this is an important distinction between sort of the kind of implementations that we see. Now, in all cases, I should have mentioned this right from the beginning, in all of these implementations, we're always talking about, especially in the kind of work that we do with our clients, it's always private permission blockchains. It's not sort of Bitcoin or permissionless systems. These are all the permission blockchain implementations that we tend to get involved in. The next sort of slide, so a little bit more background, so why all the excitement, a little bit of a repeat from the previous slide. You have sort of a number of institutions, and you have a lot of databases and repositories, and a lot of information and messages going back and forth. And that's sort of what you see today. With this kind of technology, you can actually eliminate all of that and use a ledger as a mechanism for exchanging information, and it's faster, secure, more efficient, and hopefully cheaper as well. So one of the big areas that we see a lot of applications and a lot of use cases is in the reconciliation space. So this is sort of the first phase of, especially in financial services, there are a lot of applications where data exchanges and reconciliation is actually a very costly endeavor. And many departments in large financial institutions are set up to deal alone with this reconciliation problem. So if you look at a financial services ecosystem, you'll find that you have a buyer on the left, a seller on the right, and this diagram you can sort of rewrite in many different flavors and different variations of this. But what you have is sort of each of these institutions and each of these different participants have their own data repositories. They store information about the transaction in their own repositories, and they use that for validating the transactions and recording them and for auditing purposes and so on. So when you get a transaction from a buyer and a seller and everything sort of going from left to right, and then subsequently right to left and completing the sale or the movement of this transaction, you create a lot of different individual, very granular silos of information and lots of transactional information that goes with that. In addition to that sort of opens up this whole reconciliation discussion, because you'll end up with lots of internal reconciliation, lots of departments within financial institutions that perform a lot of interdepartmental, transaction reconciliation, interinstitution, and then finally across institutions as well. So the task is actually very, very big. About a month and a half ago, there's a point of view that was published by us. We did a survey with a number of large financial institutions, global big sort of big banks, and we actually analyzed the amount of the cost associated with performing this function for their organizations. And the value of that, the number of that is actually quite large. I encourage you to download the report, or if you can't find it, please contact me and I'll get that to you as quickly as possible. It's actually very interesting because a lot of the departments, there's a high degree of reconciliation activity and where you can use blockchain to eliminate the cost associated with that. So where does blockchain and, well, distributed ledger technology fit in? At the end of the day, what we're talking about is actually replacing a lot of those silos with a single common ledger that all these participants use. It's not an easy task, clearly, but there's a huge undertaking underway to actually look at how you actually implement this kind of stuff. And what that enables is basically the ability to record transactions in the ledger. So every single one of those transactions that we talked about before, instead of having specific silos of those transactions recorded, you'll have them recorded once in a ledger that's shared amongst everybody. And you'll have the transactions that are protected at the data level itself. So the ability to actually say, well, you know, I don't want everybody to see every trade that I've ever performed, but the two participants, or the two parties of the trade, and a regulator will be able to see that information. And so we encrypt the data at the data element level, and so the actual transactional details are protected from others being able to view that from a confidentiality perspective. So this is an example of what we actually are working on with a lot of different organizations. This is more of the back office usage of blockchain technology for optimizing back office operations, and is a huge cost component to a lot of large institutions that we work with. So a lot of applications of this kind of reconciliation function. Before I get into a lot of the other stuff, I'm going to talk. So what we talked about initially in the first slide was really around the tokenization and the messaging. So if we take a look at clearing and settlement, we also find that we actually, because we have the ability to send obligations back and forth, and because we've decoupled the message from the tokens, we can actually create a lot of transactions, and then at an optimal point in time, actually settle those transactions at the right optimal point for a particular organization. So we see a lot of uses for this, specifically because optimal today, there's very little options because you end up sort of doing end-of-day settlement. But if you can use this technology and then send the obligations back and forth, record them on the ledger, and then trigger when the right time is, and that could be based on value, it could be based on time, it could be based on risk or exposure or whatever, and that's defined by the business, then you can actually do the delivery versus payment, finalizing that through a tokenized asset exchange that you have on a ledger. So by doing this kind of, sort of performing these kind of transactions, decoupling the tokens from the message, you can create lots of messages, and then tokenized asset movement to settle the transactions afterwards. Again, what's optimal will depend on the business that you're in and how that's implemented. So that's sort of the kind of high-level view of some of the use cases that we're implementing. But we always get the request, like, what is what's the best use case for us? And we actually end up spending a lot of time filtering those out. And we've come up with a quick criteria. I have a more detailed one at the end of this presentation, but this is a quick sort of test to actually determine whether a use case is a good one for a blockchain or a distributed ledger application. So first of all, if there are multiple validation and control points, so if there's multiple entities that are providing some form of validation and they have a control function, this is a great example of where you can apply DLT or blockchain technologies. If there are multiple actors involved, so you have other parties, other participants, external regulators involved, other parties in the ecosystem. We talked about reconciliation, but when there's a clear case for optimized reconciliation, a need for auditability, so making sure that you can see every single transaction that's been recorded. And then when you have a very clear need for a data lineage, so you know that a transaction that has been occurred, you know the origin of it, and you know the entire history since the very beginning, or of an asset, or of an identity, or whatever it is that you're implementing. So if you quickly look at this and you say, well, does it pass this test? I mean, the application that I'm considering using blockchain, does it pass the test of these 5 criteria? If it ticks all 5, probably a good candidate. If it ticks none of these, it's definitely not a good candidate, and you should move on and try to find something else. So we've somewhat distilled this into these 5 key criteria. Okay? I have a more detailed view of this as well a little bit later. So I want to talk about examples. I wanted to give you the background beforehand because it's sort of explaining where some of these come from. There are a lot of use cases that we are working on, and this is sort of an inventory, if you want to call it that. And there are a variety of different levels of maturity of this. So now, just to be transparent about it, this ranges from anywhere from paper proofs of concept, paper POCs, all the way through to sort of real proof of concepts, pilots, and actual production implementations that we're rolling out. So there's a lot of financial services applications. If you take a look at the left-hand side of this slide, it's all around payments, finance, insurance, and capital markets. On the right-hand side, there are a lot of other non-FS applications, public services and data, customer data, identity, and so on. And we've been implementing a number of these, again, in our labs, with our clients, some in production, some in pilots, to prove the point that these are valid use cases for using this kind of technology. And again, I just want to emphasize, all of these are sort of private permissioned blockchain implementations. They're not permissionless systems. So the next slide I want to talk about is really what's happening out there. So I spent a little bit of time sort of compiling all the different projects that I've been involved in and that I know that others are involved in my organization. This is by no means a complete inventory of what's happening out in the world. This is just the stuff that I'm actually seeing. So we've broken it down in this slide into 3 different categories. The first one is POCs. So conceptual, they may end up actually developing some sort of a prototype as well. Projects where you're actually implementing some sort of conceptual proof of concept. The next one is pilots. So pilot implementations where we're taking production data or real customer data and maybe sanitize that data, run it through a sort of a pilot implementation to prove that this will work in the environment. And then finally, production builds. So I was very surprised last year. I mean, I have a slide in a sec that talks about it, but I was very surprised last year that we had a couple of customers come to us that said, we want to implement this, we want to put it into production. We believe the use case, we believe the business case. It's a very well-defined sort of business case for this, and we want to implement this and put this into production. We want to skip the pilot phase of this and aim straight for a production build. And so I was very surprised by that, actually. But what we're seeing, it's more and more, and I expect that at the end of this year, we'll probably end up with a number of those kind of similar implementations. Those production implementations are taking the technology of blockchain, applying it in a very well-defined and focused area. Some of it is in money movement, some of it is in other areas, and I'll describe that in a sec. But applying it to actually solve a very specific problem that they're actually observing, that they have. This technology is the only one that really could solve this problem in this way, and I truly believe that now we're actually beginning to see these kind of implementations more and more. The next, okay, so this is sort of a little bit about where I keep sort of putting this slide up, and I keep asking myself, are the dates still valid? As I said before, 2016 was at the end of 2016 was really around the early adoption, the beginning of that, and what we were seeing there is actually the actual implementation of production builds. So early adoption by all means, and we're now, I think, in 2017 and so on. I think we'll end up with a lot more of those. There will be a lot of applications that will grow and implementation over the next 6 years, and then I guess full maturity, I guess, in 2025. I'm not quite sure if that's still a valid number or not, but we've got to put something up there anyway. So I think this is, when we say maturity, we mean sort of, from our perspective, As Accenture, end up building a lot of large-scale production systems for our clients. This is sort of the large-scale systems integration, big projects in government, in banking, builds of core banking platforms and stuff like that. So when we say maturity, we mean this stuff will be equally valid, viable option of implementing a system of some sort using this technology versus any traditional technology that we have available today. So just to put it into perspective, I think maturity, there will be a lot of developments that'll get us there up at that point in time. This slide is really, and I'm glad that the session this morning talked about central banks. I've actually been very fortunate because in my time at working as a sort of blockchain lead for Accenture, I've actually worked with a number of central banks. So now, and there is a very specific challenge that is being faced. We can talk about it a little bit later, but what we actually did, we worked with one of them and we had a brainstorming session, and it was sort of a very collaborative, very long session. And we gathered some of the ideas, and this is the output of that session that we worked on with a couple of them. The whole idea was that when is it going to be a tipping point? And what do we mean from a central bank perspective that this is a tipping point for blockchain or distributed ledger technology? So we sort of painted this picture, this journey, 6 points that you have there, now and sort of 5 years into the future. And there's sort of two key tipping points. One is around the blockchain infrastructure, so things starting to come together when we talk about clearing and settlement, and there are a lot of people who are actually working on this problem. And I think we're definitely not there yet, but we will get to that point in the very near future. And the next one is the virtualization of fiat currency, and that's specifically with the G20 country, because I think that that will be the actual true tipping point of this technology. When a large G20, or G20 by definition is large, government will actually tokenize its currency, a fraction of its currency, put it out there in the market, and put it in the hands of either institutions or consumers or users or both or whatever. That's the beginning of something that I think will be truly transformative in the wider economy. The reason for that is because no matter what we talk about, I mean, I can show you all the lovely slides of all the different systems of everything we're doing with blockchain and distributed ledger technology. When it comes to performing, doing sort of the asset movements and so on, it comes time to settle. And settlement requires some form of value, and I need that value to be something that has the liquidity, that has the trust component behind it, and that's where tokenized money actually will play a key role in that. We work with exchanges as well and market infrastructure providers, and that's the missing link, actually. That's the missing link of the entire sort of ecosystem. So I don't believe we're far off. I've been working on projects specifically to focus on that one challenge. And of course, with clients shall remain nameless. But at the end of the day, it is absolutely fundamental that this is something that will create sort of the tipping point of this technology, and also facilitate many other implementations and other systems that we put into production. So I talk a little bit about some of the other use cases, and here we just have a slide that talks about sort of what are the value and effort associated with implementing some of these, and when we do sort of an assessment of that and an evaluation of that, there are many different methods that we look at from an evaluation point of view. Clearly, high value, low effort is the best ones, and we have identified a number of those, and we tend to focus and prioritize when we build systems for clients that have that around those. This is some of the artifacts, just to show you sort of how we actually do some of that. On the upper right-hand corner is sort of a complete sort of assessment of all the different potential use cases for a very large institution. We then obviously filtered out, weeded out all the ones that we thought were somewhat irrelevant and focused on the ones that were in the upper right-hand quadrant. And those are the low effort, high value, and strategic benefit for the entities that we work with. So that's just couple of things to show you how to do that. In here is the detail of the framework. So what are the things that we look for? So those 5 key points that I mentioned before, so applicability and from an applicability point of view, come from these 3 slides. And the whole purpose of it is to just give you some sort of a framework, things like reconciliation, resilience, availability, and confidentiality, and so on. I wasn't going to talk to the slides. I just want to show you what the framework looks like. The next sort of point that I want to make is in my journeys and travels and everything. I've been working on this topic now for the last 3 years. I have a fundamental belief that this stuff will never go mainstream unless two key things happen. The security of the systems that we're building are addressed, because today there are a lot of concerns regarding security and the scalability of the solutions that are out there as well. So from a security point of view, at the end, the assets that you're protecting are keys. So the key is the asset. So fundamentally, if you're not protecting the keys properly of these tokenized assets that you're moving around, you're actually compromising yourself in a much more significant way, or potentially compromising yourself in a more significant way than you would through a traditional IT system, traditional system. The reason for that is where you store the key and how you manage the key is fundamental. Everything is around the key. So, and this is one of the reasons why we've also invested a lot in trying to address this particular problem. So security requires that you provide sort of proper key management. This is something that's been happening in the banking world now for 20, 30, X many years, many years actually, using sort of hardware devices, using proper key management techniques and so on. And what we did actually about this time last year, and for a period of about 7-8 months, we started developing a solution that allows us to protect the keys of any blockchain implementation in a way using sort of hardware devices, in a scalable architecture that is much more comprehensive, and I'll show you a little bit about what we mean by that. But security is fundamental. And none of these systems, in my humble opinion, will ever go mainstream. I will never sign off on any system to go into production unless security is rock solid. The exposure is much more, and you need to make sure that you have security addressed properly, and security is a very comprehensive area as well. The next topic is around scalability. And scalability as well is key. It's fundamental that, number one, the technology is scalable. You're dealing with lots of different keys associated with that, and you're able to archive data and go back and have sort of you don't want runaway sort of blockchains that are massive in size and become unmanageable. So scalability is also fundamental to all of this as well. And we have a number of things that we've done around that. So you may have seen in the press in the last couple of weeks, it was in the New York Times and everywhere else, sprayed everywhere else. CoinDesk as well has the most comprehensive article about this. This is my brainchild, actually. I started this off about a year ago, and actually it was even longer than that. It was a couple of years ago when we initiated this. But we actually implemented a solution that allows us to do proper key management with using hardware devices, and actually using a device like this to store all the keys that are associated with any implementation. So if you have a wallet, if you have any of the private keys that are associated with that, they're actually stored on a hardware device, and we worked with Talus to actually do that. But the architecture is really the more important thing, because what we're doing here is developing sort of a high-level, business-focused application architecture at the highest level. And we have this prototype working in London. If you're in London and you want to have a look, just please let me know, and I can showcase that to you in our offices in Fenchurch Street. We have a mobile banking application that uses this entire stack that we've implemented using Hyperledger Fabric, and then we have a number of APIs that we've implemented to do sort of all the blockchain management, and then underneath that doing sort of all the key management in hardware devices, so no keys are ever exposed and can't be copied and can't be tampered with and so on. So this is an architecture that we've designed and built that enables that kind of sort of management of keys. And it's a fundamental part of what we need to make sure that these solutions go into sort of production and so on. So that's all the slides I have. I'm sure you probably have a lot of questions, and I want to make sure I leave enough time to take some of the questions as well.
John, great. Thank you very, very much. Should we take some questions? Oh, good, you're getting off lightly today. Great. Anything else you want to add? Good.
That was it. I mean, I'm sure anybody have anything? No?
Please feel free to engage with John over tea. Or there we go. There we go.
Okay.
Thank you.
Slow after lunch, right?
It is. we got to warm up this
Yeah,
crowd.
warm up the crowd. That's it.
Yeah.
So great
exactly.
presentation. I just wanted to find out from you with the storing of the keys on hardware. I mean, as you know, any hardware connected to a network is vulnerable to attack. Does that not provide a single point of failure so that the keys, if those are lost, I mean...
True, that's a very good point. So there's two aspects from a hardware perspective. One is key generation, and the other one is key storage. So key generation, if you know sort of some of the attacks that have happened over, with regards to some of the exchanges and wallets and in the Bitcoin world, have been around lousy random number generators. So if you implement a solution in software alone and you have a corrupted system or compromised system rather, that generates a lousy random number generator, you're generating a key, basically an address, a key that somebody else could potentially know the private key of, right? So what we've done, and these devices are government certified, bank grade certified, these are the kind of things that we use in many financial applications. We use the hardware random number generator that's in the device to actually generate a true source of randomness. There's actually a physical element. It's a noisy diode that generates a random number through the random number generator function. So the risk of compromise of using a corrupted or compromised random number generator in software is mitigated, right? So that's risk number one. The second one is around key management. So if you're generating the key in the hardware device and the key never leaves the device, then the risk of that key going missing or being copied or cloned actually is reduced, minimized, and what you're doing there is that you're creating a secure environment where these keys exist and they never leave the device. Of course, there's backup mechanisms that you can clone these two devices, but they require a high degree of privileged admin access rights in order to do that in a very secure environment. Okay?
Thanks, John. Any more?
Yeah.
So, a microphone to the middle.
Thanks, John. Accenture made some waves last year.
Yes.
With its lovely claim to edit the blockchain. Yes. So your thoughts on where that's come from, what the thinking was, and where it's going to?
I knew somebody was going to ask. That's why I left enough time at the end. So this is a solution that actually I've been working with Professor Atenise on the development of the prototype around this solution. And it's specifically designed for enterprise applications or private permission blockchain solutions. So it's not intended for Bitcoin. So it's not, Accenture didn't break Bitcoin, right, at the end of the day. So just be very clear about that. The reason why we implemented or why we designed, why we developed this thing and patented it as well, is specifically to be able to address the need that large institutions need to have a fallback mechanism when things go terribly wrong. And with the right governance model, because at the end of the day, you can't just compromise. You can't just go in and change something without having a full audit log of the event, and B, a number of agreed upon participants up front. So you have to agree up front that, let's say, 8 of the 10 of us from a governance perspective will come together and we will make this edit because we have to do this edit. We either legally obliged to do it, maybe there's a court order, there has to be something that says, I need to remove that person's name for a right to be forgotten, as an example that's given in the paper. There's also administrative controls as well. There's a reason for this, and that was a bit about the scalability aspect of it as well. So imagine you have 8 years worth of data, right? And your data retention says you only need to keep 7 years. These blockchains will continue to grow, right, at the end of the day. So if you can't just cut off, prune, and remove things without compromising sort of the integrity of the entire blockchain. So the idea about developing this was that we could, let's say, in the last year of those transactions that are no longer, or the first year of the transactions where they're no longer required, we can net the positions and then create a new block and edit the blockchain and say, prune all this data out, add this one block in that nets all these positions, and now we can carry on, and the integrity of the blockchain remains intact. I didn't bring the demo. I can show you the demo through another source, through another way. But that's the idea and the purpose of it. We've had almost every single one of our clients that we've spoken to about this absolutely get it, besides all the noise that's been created about it. Maybe that was a bit of marketing deliberate activity. Yeah.
Why would you want to patent that?
Why? The patent is not intended, I mean, at the end of the day, we've patented a number of things. We're not going to commercialize the patent. We may even consider open sourcing it as well at some point. I don't know. It's not from a commercialization perspective. None of our patents are ones that we sort of, pursue people with and stuff like that. So we did it because we want to obviously protect some of the IP behind it, and because there's some clever stuff in there.
Go take one from over there.
Hi. Is working? Hi. One of your use cases for the blockchain was customer data.
Yeah.
Okay. One of the weaknesses I see in the system is data privacy and customer protection. Like anyone can see what happens on the blockchain if they know my wallet address. And what if an asset, like you mentioned about security, what if an asset is stolen? Can it be refunded? Can you tell me more about the risk involved?
So the whole idea behind, I guess, designing these systems is that when you talk about stealing an asset, that means that you've compromised something, right? So something has been compromised, whether it's by design through the random number generator of the private keys, which hopefully you address through hardware implementations. But in software mode, that has actually happened, right? So that has occurred. So in that case, it's been compromised because you've implemented it incorrectly. And that's where a lot of due diligence needs to be done upfront in the design and implementation of these kind of solutions. So I guess you asked a couple questions. The data privacy angle of it, I think when designing these systems, we're not intending to put sort of people's personal information straight onto the blockchain and visible by everybody. At the end of the day, that's somewhat of a design issue of if you're thinking about doing stuff like that. It's more about putting sort of transactional information, things that have occurred between participants, not necessarily people's names and IDs and passport numbers and stuff like that. So I think a lot of work has to happen in the identity space to properly design solutions that are privacy protecting, and so that things like that don't happen, right? So when you're implementing sort of the solution as a whole.
So how do you think you can integrate our current system with regards to data privacy into a DLT system?
Which current system?
The way information is kept private at the moment,
Yeah.
and implementing that and keeping it private in the distributed ledger.
Well, I think, as I mentioned here before, these systems that we're designing and building are not public and open, right? At the end, they're basically intended to be private and permissioned, and these are the same. Let's assume that this example that you're talking about is information that's exchanged amongst a number of government departments. They would have access to this information anyway. What we're doing here is, if we design and build such a system, we're designing it so that the information is protected and is still viewable by these different entities. So it's no different than what we would have implemented already, except for now you can actually design it and model it in such a way that you can protect the privacy off the chain and doing other external references and so on behind that.
Great, John, thank you very, very much.
Thank you.